Hello students, in today's lecture we'll be doing fluid dynamics and we'll be covering equation of continuity. Fluid dynamics means fluid is in motion with respect to the container or pipe in which it is present. So equation of continuity, it's a simple equation which is based on the conservation of mass. Mass entering through a cross section of a pipe must be equal to mass leaving through another cross section of the pipe per unit time. So in this diagram, we can show you that this is a pipe having variable cross sections. At this point, cross section is A1 and at this point, cross section is A2. The fluid is moving with the velocity V1 at this point and with velocity V2. There is any random cross section which may be parallel to these cross sections or may not be. But through all these three cross sections, the amount of mass entering must be equal and the amount of mass leaving must be equal if the pipe is completely filled with fluid. So we can say mass entering and mass leaving. Mass entering in a small time dt, this cross section will move by a small amount v2 dt as the cross section has a velocity v2, and this cross section will move by a distance v1 dt as the velocity is v1. So we can say the volume is a1 into thickness or the width a1 into v1 dt, similarly a2 into v2 dt, and rho are the densities at these two cross sections. If we can assume that rho 1 is equal to rho 2, the fluid is not changing its density, we can say a1 v1 is equal to a2 v2. This is the basic equation of this is the fundamental equation of continuity, and it says rate of volume, rate of flow, which is volume per second throughout the pipe, is constant no matter what cross section you choose. This is I was talking about that A1 V1, which is the rate of flow. It is volume per second, is same throughout the pipe no matter what cross section you choose. Maybe it's parallel to flow, perpendicular to flow, or at some angle with the flow. So one example, that the fluid is coming from cross section A3, having area of cross section A3 with speed V3, and from this cross section having area A1 with the speed V1, and these two fluids converge and they are coming out with velocity V2 from the cross section A2. We have to find the value of V2 in terms of A1 A2 A3 and V1 V3. So we can say that rate of flow of this side plus rate of flow of this side will be equal to the rate of flow of the second side. So we can say A1 V1 plus A3 V3 must be equal to A2 V2. These are the values of A1 V1 and etc. You can solve for V2. V2 comes out to be 15. Means fluid is moving out with speed 15 meter per second from this point or from this cross section. Here's another important example in which you have to find in this cylinder there are n small holes having each cross sectional area small a, and a big piston which is having a cross sectional area of capital A. The piston is moved or pushed with the velocity v, and the fluid starts coming out from these holes with some velocity u. You have to find u in terms of capital A, v, and small a. Again, using the equation of continuity, we can say the amount of flow shifting this side must be equal to the amount of flow leaving through all these holes added together. So we can say A1 V1 is the amount of flow or rate of flow from this side must be equal to n times, because there are n number of holes, and rate of flow through each hole. So we can get the value of u as A capital V by n small a. Another important example of equation of continuity is that there is a tap having cross-sectional area capital A, out of which some water is flowing out with a steady flow, and we have to find that the cross-section of that flow which it will become after it has fallen through a height h. So that is the face of the tap, and it is water is falling from this point and it is getting narrowed down. When it has fallen through a height edge, we have to find this small cross section when it has fallen through a depth edge. Rate of flow is given. So first of all, we'll calculate the velocity at the initial cross section using rate of flow as AV. So initial velocity of the fluid with which it is coming out from the tap is Q by A. Again, we can use Bernoulli's equation or just simply energy conservation. We can get the velocity of the fluid at a depth h by using final velocity square is equal to initial velocity square plus 2gh as this, and using again the rate of flow will remain same as the flow as the liquid is not going anywhere else, just moving through this cross section. So we can say the rate of flow will remain q, and v dash, oh sorry, a dash comes out to be q divided by v dash. This is the value of v dash. Just plug it here to get the value of this. uh, Thank you. That's all for equation of continuity, and you can watch Bernoulli's equation for detailed explanation of related question of Bernoulli and equation of continuity. The complete fluid dynamics will be covered in that.